These are the Prism Notes. Prism Notes, not Prism Notes. Prisms. So we don't really care about the definition of polyhedron. A polyhedron is a solid 3D object with flat polygonal faces. We're not too interested in that. What we're interested in is the definition of a prism. So a prism is a polyhedron, meaning it has, that's why we're interested in polyhedron, because it's part of the definition of a prism. So a prism is a polyhedron, meaning it's three-dimensional with flat polygons as all of its faces. Okay. So it's a polyhedron comprising of an n-sided polygonal base, polygonal, I'm not really sure the correct way to say it. So n-sided polygonal base. So if you look at our examples below, the bases are all going to be polygons. Here we have quadrilaterals, here we have triangles, here we have pentagons, here we have hexagons. So they're going to have some number of sides. Then it's going to have a second base, which is a translated copy of the first. Actually, let's put those up. So, okay. So it's a polyhedron, meaning it's three-dimensional with flat surfaces. It's going to have an n-sided polygon as its base. So here we have a four-sided polygon, three-sided polygon, five-sided polygon, six-sided polygon. Okay, the second phrase here says a second base, which is a translated copy of the first. So we're going to have two bases each. We're going to have the top and the bottom, two triangles, two pentagons, two hexagons. Okay, and then n other faces joining the corresponding side. So for example, here we have n equals 4 because it's a quadrilateral. It's rectangle. So there's four sides. So we have a rectangle, a four-sided polygon, and a translated copy of that four-sided polygon on the bottom. Then we have a front and back, left and right. So there's four sides, four other faces. Okay, joining those two bases. So we have the base at the bottom and the top, and we have four sides of the rectangle joining the bases. Here we have two triangles, and then we have three sides joining, three rectangles, three sides joining the bases. Here we have five sides joining the two pentagon bases, and six sides joining the two hexagon bases. Okay, so this one was a rectangular prism. Angular prism. Okay, this was a regular triangular prism. Triangular because it's a triangle. Regular because all those triangles are going to be the same size, the same length. They don't have to be. But for our purposes, they're going to be. Okay. So we really can just call it a triangular prism. Let's call this a pentagonal prism. And here we can call it a hexagonal. Okay, and again, for our purposes, these are all going to be regular, but we don't necessarily have to write regular. So triangular prism, pentagonal prism, hexagonal prism, rectangular prism. So example 1 wants us to find, so we have example 1, 2, 3, and 4 are going through the 3 steps. 1, 2, and 3 are going through the 3 steps to find the surface area. Then example 4 is finding the volume for A, B, and C, the figures A, B, and C here. So 1A connects to 2A, which connects to 3A and 4A. 1B to 2B and 3B and 4B. So base area is just going to be the area of base. So in the prism, it's going to be length times width because it's a rectangle. Triangle, it's going to be 1/2 base times height because it's a triangle. For the hexagon, it's going to be 3 squared to 3 over 2 times the side squared because that's how you find the area of a hexagon, regular hexagon. Okay. So let's find these areas, the bases. So here again, we have 2 bases. Okay, let me get I had a sheet. Okay, so here it's a rectangular prism box. Okay, the base we're going to say is the bottom. So there's 2 bases, the bottom and the top. We notice the top and the bottom, they are rectangles. So if the bottom are rectangle, the area for rectangle is length times width. So the area here is going to be 8 times 4, which is 32 meters squared. Okay, and we have two bases. Okay, base on the bottom, base on the top. So the bottom's 32 meters squared. The top is also going to be 32 meters squared. So we're going to have 32 plus 32. It's going to give us 64 meters squared. Okay, the 64 meters squared represents the area of both the bottom base and the top base added together. Okay. Triangle. Okay. So here we have a triangular prism, a regular triangular prism, meaning that our sides are 10, 10, and 10. Let me actually delete this. We need more room for the triangle. Okay, so here's our triangle. The sides here are 10, 10, and 10. So if I draw our triangle out, we have 10, 10, 10, and 10. We need to find the area of this triangle. The area of the triangle is 1/2 the base times the height. The base of our triangle is going to be 10. We need to find the height. We don't have the height, so we need to find the height. So we draw an altitude. Okay, the altitude in a regular triangle is going to bisect and be perpendicular to the base. So we're going to bisect it. So this is going to become 5 and 5, and these are going to become right angles. If we have right angles, we have right triangles. If we call the height x, we can then find x because we have right triangles and we have the hypotenuse in the other leg. So we're using then the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, the legs of the right triangle, the a and the b, are going to be the x and the 5. So x squared plus 5 squared equals 10 squared. 10 is the hypotenuse. So it's x squared plus 25 equals 100. Subtract 25 from both sides, we get x squared equals 75. Okay, get rid of the square. We take the square root of both sides, so we take the square root of 75. I don't know the square root of 75. It's going to be 8 point something though, because it's because it's between 64 and 81. So it's going to be between 8 and 9, closer to 9. 8.7. So 8.7 is the height of this triangle. The reason we did this was to find the height of the triangle. So our height is going to be 8.7. So 8.1/2 times 10 times 8.7 is going to give us 43.5. So our area of the triangle is going to be 43.5 meters squared. So again, we wanted to find the area of this triangle. Okay, there's two bases. So we want to find the area of the triangle. The area of a triangle is 1/2 the base times the height. We had the base, which was 10. We needed to find the height. In order to find the height, we drew an altitude. Okay, that altitude, since it's a regular triangle, it's an equilateral triangle, it bisected the base, splitting it into two pieces of 5. And it also was perpendicular to the base, so it would form right angles. Since we had right angles, we could use the Pythagorean theorem to solve for that height. So it was 5 squared plus x squared equals 10 squared. We solved for x, it was 8.7, so we plugged that into the height formula. To the area formula for the height, and we're then able to find the area of that triangle. So the area of this triangle is 43.5, but there are two triangles, so 43.5 plus 43.5. It's going to give us 87 meters squared. I don't know why that took so long. Okay, so the area of the two bases added together is 87. I think we're going to need these numbers, so I probably should write them down. So what do we get, 64? For A. For B, we're getting 87. 43.5 or 43.5. Okay. For the hexagon, okay, we're given the area of the hexagon here is 3 over 2 times the side squared. So the side of the hexagon is 4. So the hexagon is going to be 4, 4, 4, 4, 4, and 4. Okay, so that's going to be 3 over 2 times 4 squared. So all we do is put that in our calculator. Three square root of 3 divided by 2 times 16, 41.6. Feet squared. Okay, there's 2 hexagons though. So the area of both of those hexagons is 41.6 plus 41.6, which is times 2 is 83.1 feet squared. So let me write that down. Then one of them was 41.6. Okay, so those are the base areas. Those are just the area of the top and the bottom of the prisms. Example 2, we're going to find the lateral area. So the lateral area, so each prism has 2 bases. Okay, the lateral faces are the faces that are not the bases. The bases. Faces that are not the bases. The lateral area is the area of all the lateral faces. Area of all lateral faces. Okay. So if we look at our rectangular prism, pull back out our box here. We had 2 bases. The top and the bottom were bases. Okay, we found those bases, each one to be 32 meters squared. Now we have 4 other sides. So top and the bottom were each 32. We found that in example 1. Now we're using the front and the back, and the left and the right. Well, if we look at the front, okay, here's a rectangle. The area of a rectangle is length times width. Okay, so the length and width in this one is 8 by 8 and 5. So 8 and 5. So that's going to be 40 meters squared. The back of the box is going to be the same as the front of the box. Okay, it's going to be 40 meters squared. It's going to be 8 by 5. So we have 2 40s. 40 plus 40. Okay, and then we have the right side and the left side. Okay, that's the right side and the left side of our rectangular prism. So the right side and the left side. The area for the right side and the left side is going to be 5 by 4. They're rectangles. Okay, they're going to be 5 by 4. So area of a rectangle is length times width. So that's 5 times 4, which is 20 meters squared. And there's 2 of them. Okay, so we got to add our 4 lateral sides together. So our bases were 32 and 32. We got that in example 1. Here we're getting the front and the back. We're 8 by 5. So that was 40 and 40. The front was 40 meters squared. The back was 40 meters squared. We found the right to be 20 meters squared and the left to be 20 meters squared. So there's 2 bases, 4 lateral faces. The 4 lateral faces, 40 plus 40 plus 20 plus 20, is going to add up to 120 meters squared. Okay, so that's going to be our lateral area. The area of the 4 lateral faces. 2 bases, 4 faces. 4 lateral faces. For a total of 6 total. Okay, if we look at the triangle, okay, again, this is 10 and 10. These are going to all be 50. Okay. So if we look at a triangular prism, I tried to make one on paper. Okay, so one triangle here, one triangle here. Okay, it's not bent in the right way, but we have 2 triangles. Okay, and that's going to be the top and the bottom. Okay, and then we're going to have 3 sides, 3 lateral faces. 1, 2, and then the back is 3. Okay, so you have 3 rectangles here. 1, 2, and then the one in the back. 3. We found the area of each triangle to be 41.5. So we found the 2 bases were 41.5 and 41.5. Now we need to find the lateral area. So the lateral area, again, they're all rectangles, so the length times width. So that's going to be 10, right? These are all 10. 10 times 5 times 50, which is 500 meters squared. And there's 3 of those rectangular sides, so 500 plus 500 plus 500, or 500 times 3, because there's 3 of them. Which is going to give us 1,500 meters squared for our lateral area for our triangular prism. Okay, and then the last one is the regular hexagonal prism. We found the area of the top to be 41.6, the area of the bottom to be 41.6. Okay, now we need to find the lateral area. There are 6 sides. Okay, it's a hexagon. So you have 1, 2, 3, 4, 5, 6 rectangles. So the area of each rectangle is length times width, which is 4 times 12. Right? So all these lengths are 4, and all these lengths are 12. So it's 48. And again, there are 6 of them, so 48 times 6. 50 times 6, so that's going to be 288 feet squared. Okay, the lateral area is going to be 288 feet squared. I'm going to write those 3 down. So for number 2, we got 120, 1,500, and 288. Sample 3, we want to find the total area, or surface area. The better name for total area is surface area. So you can really cross it off if you want, or just write surface area. Okay, and our surface area is going to equal our base areas plus the lateral area. So we got to basically add our answers from number 1 and number 2. Okay. So let's give ourselves some room. Okay, so finding the total area or the surface area. Okay, if we pull back our rectangular prism, we found the top to be 32 meters squared and the bottom to be 32 meters squared. We found the front to be 40 meters squared and the back to be 40 meters squared. And we found the right to be 20 meters squared and the left to be 20 meters squared. Okay, right, we had 8 times 4, 8 times 4, then 8 times 5, and 8 times 5, and then 4 times 5, and 4 times 5. Okay, so our total, the area of our 2 bases added together was 64. Okay, again, or 32 plus 32. Okay, and then our lateral sides, right, were 40 plus 40 plus 20 plus 20. right? So we found our lateral area to be 120, and we found our base area to be 64. Right? That's those two, and this is these four. So we just simply add those two numbers together, and we get 184 meters squared. So that's going to be our surface area. Next one is the regular triangular prism. We found the area of both bases. So again, here's our triangular prism that I've kind of folded. Okay, we found the area of the top and the bottom to be 43.5 each. So we have 43.5 plus 43.5, which we then found to be 87. So the base area was 87. Then we found the lateral area to be 1,500. So we had three rectangles, each was 500. So that was plus 500, plus 500, plus 500, which came out to 1,500. So we add the base area, the area of the two bases, to the lateral area. That's going to be 1,587 meters squared. That's our surface area for B. Okay. And then C, the area of our hexagons were 41.6 each. So we had 41.6 plus 41.6. Okay, and that gave us, again, we rounded, so our next answer is not exact. We got 83.1, which is more exact than those two. We rounded those a bit. Okay, and then we found each one of our rectangles was 48, and we had 6 of them, right? So we had 48 plus 48 plus 48 plus 48 plus 48 plus 48. We found all that to be 288. So 288 plus 83.1 equals 371.1. That's feet squared. Okay. So the way to think about these surface areas is how much wrapping paper, if these were presents or boxes and you're trying to wrap them, how much wrapping paper would you need? So for this one, we would need 371.1 square feet of wrapping paper to cover all the surface of this regular hexagon. Here, I forget what the answers were. Can we go back far enough? No, we can only back one. So whatever answers we got here, that's how much wrapping paper or meters squared of wrapping paper we would need to cover this whole rectangular prism. Okay. Volume is example 4. So the volume for all prisms. So we're just doing right prisms. Okay, that's all it's the same. So the volume of a right prism is going to be the base area times the height. So the volume is going to equal the area of one base times the height of the prism. Okay, the area of one base of the prism times the height of the prism. Okay, so let's find the volume of the first one. Okay, we use the bottom as our base, so we want to find, again, we found this to be 32. Okay, then we want to multiply by the height of 5. So the way you want to think about this is as a swimming pool. So say you had a rectangular shaped swimming pool. You want to find the area of the bottom of it. Imagine an infinitely thin layer. The amount of space it takes up to cover the bottom is 32, 8 by 4. And we want to multiply by how high the water is. So say the water is 5 meters high in the swimming pool. We would need 32, the area of the base, times the height to find the total volume of water in the pool. So 32 times 5 is going to be 140. It's going to be 160. Yeah. Square. Again, volume here, same formula. Volume equals the base area, the area of one base times the height. Okay. We found the base of this triangle. So again, think of a swimming pool, a triangular swimming pool. You need to cover the bottom of that pool. Okay, with the area of that we found to be in part 1, 41.5 meters squared. So it took 41.5 meters squared of space to cover the bottom of the pool. And then imagine the pool was 50 meters high. It's an enormous pool, but imagine it was 50 meters high. We would then need to multiply by that height to find the amount of water in the pool. You have to take the area of the base at the bottom, cover up that area. That's to cover up that area takes 41.5 meters squared. That's how much the area of the bottom is. Then you need to multiply by how high the water is. And if it's 50 meters high, we multiply by 50. So 50 times the area of that base, 41.5, it's going to give us 2,075 meters cubed. Okay, and the last one, we found the base to be 41.6. Okay, so the base of our hexagonal prism, the hexagon, was the area of the bottom. So imagine a hexagon-shaped pool. Okay, the area of the bottom of the pool is 41.6. We found in part 1. Okay, and then we need to multiply that area by the height of the water, 12, to find the volume of the water in there. So it's 41.6 times 12 feet. We're getting 499.2 feet cubed. And again, it's cubed because it's three-dimensional. Right. The base area of the base was feet squared, 41.6 feet squared, times 12 feet in height gives us feet cubed, 3 dimensions. Okay. There is one more example on here. And it's a triangular prism. So this is like example B. We need to find all these things. So let's start with our base. Okay, so we have 2 triangles that are our bases. So we need to find the area of the triangles. They're 6 by 6 by 6. Okay, the area of the triangles are 1/2 base times height. Okay, we know that the base is 6, but we don't know the height. To find the height, we need to drop an altitude. Okay, that altitude, since it's a equilateral triangle, it's equilateral because it's a regular triangle, is going to bisect the base. So it's going to split it into 3 and 3. It's also going to be perpendicular, so it's going to form right angles. If we have right angles, we have right triangles. So if we label the height x, we can use the fact that we have a right triangle to solve for that height. Okay, the bases of our right triangle are x and 3. So right triangles, x squared plus a squared plus b squared equals c squared. Pythagorean theorem, so our bases are x and 3. So x squared plus 3 squared equals the hypotenuse squared. The hypotenuse is 6. So we get x squared plus 9 equals 36. Subtract 9 from both sides and we get x squared equals 27. So the square, if you go to the square, we got to take the square root. So the square root 27 is going to be 5.2. Plus or minus 5.2, but we're going to use the positive. 5.2. Okay, so our area of the triangle is then, right, so the whole point of doing that, right, what we did, we were splitting the triangle, we're putting an altitude in there, it bisects the base, creates the, we can label the height x, it's perpendicular, so it forms a right triangle. So we use the Pythagorean to solve for x. We solve for x here. So now we have the height of the triangle. Since we have the height of the triangle, we can now find the area. So our whole goal was to find the area of the triangle. The area was 1/2 base times height. We knew the base was 6, but we needed to find the height. That's why we did this. To find the height so we can find the area. So area is going to be 1/2 times 6 times 5.2. 15.6 centimeters squared. Okay. There are two bases. So that's going to be 15.6 plus 15.6, which is going to give us our total at base area of 31.2 centimeters squared. So that's going to be our first one. The total base area, the area of both bases added together is 31.2 centimeters squared. Okay, want to find the lateral area now. So the lateral area, there's going to be, this is a triangular prism, so there's 5 total faces. So there's 2 bases, meaning there's 3 lateral faces. So the 2 bases were the triangles. Now we have 3 rectangles, okay, that connect those 2 bases. There's 1, there's 2, there's 3. And the triangle sides are 6 and 6. This is 10 here and 10 in the back. Okay, so our 3 rectangles, to find the area of a rectangle, that's going to be length times width. So that's 6 times 10, which is 60. And again, there are 3 of them. Okay, so 60 plus 60 plus 60. It's going to give us 180 centimeters squared. So that's going to be our lateral area, 180 centimeters squared. So the total area or surface area, okay, so surface area, okay, it's then going to be your lateral area, 31.2, plus your your base area, so your 2 bases, so 15.6 plus 15.6 are the 2 bases. And we want to add our lateral area, so plus 60 plus 60 plus 60, or plus 180. Okay, so 180 plus 31.2 is 211.2 centimeters squared. So our total surface area, again, it's just these 2 numbers added together. That's 211.2 centimeters squared. Okay, and then finally, the last one is volume. Okay, so volume. Let me go back to surface area. So surface area, again, we had 5 surfaces on our triangular prism. The front base, bottom, was 15.6. Top was 15.6. And then the 3 rectangles here, the 3 lateral faces were each 60. So 15.6 plus 15.6 plus 60 plus 60 plus 60 is 211.2. Or we can, again, add those together first, add these together first, and then we get our final surface area. Okay. Volume's area of your base, so the area of our base, the area of the triangle, was 15.6. So it's not the area of both bases, it's just the area of one base, right? Because again, imagine a swimming pool, a triangular swimming pool. So the area of the base of that pool is going to be the one triangle, which is 15.6 centimeters squared. And then we need to multiply by the height of the water. So in this case, the height is going to be 10 because the height is the distance connecting the 2 bases. So it's going to be 10. And if you put it up like this, it makes it easier to see. Here's your bases. Height is 10. Okay, so all we do is move the decimal place over. So it's going to be 156 centimeters cubed. Okay. So volume is 156 centimeters cubed. Okay. So surface area is the amount of space to cover it. So if we wanted to wrap this triangular prism up, we would need 211.2 centimeters squared of wrapping paper, square centimeters of wrapping paper. How much do we need to cover all the surface of it? Volume is how much space does it cover up. So if we were going to fill this thing with water, we could fill it with 156 cubic centimeters of